As mentioned, today I'm going to be talking about sustainability and AI and how we can balance the current climate costs of AI with future potential climate benefits. Just as a disclaimer, this is not legal or financial advice, and it represents my own views. As Anna mentioned, I am an operator, investor, researcher, and educator. I teach about AI and climate at MIT and Harvard, as well as the Google Data Center Community AI Fellowship. I built, researched, and instructed AI for climate and energy solutions at MIT's Entrepreneurship Center and did the mid-career MIT Sloan Fellows program with a thesis on the net climate impact of AI. I've also been a climate tech venture investor as one of the partners of Climate Capital's Climate Angels program. They're one of the most active funders of climate tech startups. And previously, I was an entrepreneur where I raised venture capital and exited through acquisition. And finally, I've been a board member, mentor, advisor, author, and speaker, most recently speaking about AI and climate at places like COP, Davos, and TEDx. And I'm super excited to be here with you folks today. And also, if everyone could please mute, that would be amazing. I want to take you back to why I got into this work. This is a picture of Toronto, Canada, and that's where I'm from. And one day when I was working in my education company, we woke up to this. And at one of our facilities where we were teaching kids coding and robotics, both in person and online, kids asked me, why can't we go outside? And I didn't really have a solid answer for them other than thinking to myself, oh no, the generations above you like really messed this up. And I'd done some consulting and investing in climate, but realized I wanted to devote myself to climate full time. So that's what led me on the journey that I just shared. Today, I'd like to talk about a couple things. First, an introduction to get everyone on the same page, then talk about the climate harms of AI, the potential climate benefits of AI, what the net climate impact of AI could look like, and what we should do about that. So just to start as an introduction, again, this is based on my thesis, which I did with professors John Sterman and Harvey Michaels on the net climate impact of AI. I want to get everyone on the same page. We know AI is contributing to climate change. We hear about it in the news all the time. There's these massive data centers being opened. They're causing a lot of emissions. But we also hear that AI could potentially help reduce climate change. It has lots of benefits to offer. So which is true? Well, I would say both are true. AI is both contributing to and could potentially help reduce climate change. We can see it as a double-edged sword where AI is both using a lot of energy as well as offering the opportunity to perhaps better optimize energy and reduce it. So the question is using AI for climate solutions worth it if we're not really sure what the answer to that is? So that's part of what I'm going to cover. You may already know some of these climate statistics, but I just want to share to get everyone on the same page. The last 9 years are the warmest on record by far, and emissions are the #1 cause of climate change. It was clear to me at COP that energy is one of the largest contributors to emissions at almost 70% of emissions. And also that energy-related emissions come mostly from fossil fuels, so 80% from non-renewable energy sources like oil and coal, and renewable energy sources at 21%, so those being things like solar and wind. And sorry, this is what was clear to me at COP, which is that although individual countries have made a big difference in terms of reducing their emissions, as a globe, we unfortunately have a hockey stick curve of the worst kind because the emissions continue to go up year over year. And this is leading to some bad impacts. Both those emissions and other climate factors are leading to, we have 7 out of 9 planetary boundaries crossed, according to Stockholm Resilience Center, which is very scary, especially considering as of, about 20 years ago, we only had 4 crossed. I'm not going to go into this diagram in depth, but just to look at some of them, let's say in climate change here, we can see that the carbon dioxide concentration is outside of this safe operating space. We're also starting to see ocean acidification, land system-based change, and other issues as well. So what sort of technological innovation is needed to help reduce climate change? According to some MIT researchers, we need to improve technology to transition away from fossil fuels. We need to increase the efficiency of the energy system and redesign demand to match supply. And then we need to capture things like carbon dioxide, methane leaks, and pollution as well. Now, enter AI into the picture. AI can help with each of these things. It can help, for example, do material science discovery to help come up with innovations that humans may not have been able to. But it is also hurting our ability to do each of these things because it uses a ton of energy. So my research considers both the climate costs and benefits of AI to provide an overall net climate impact score and attempt to quantify the overall climate impact of AI with some caveats. So a lot of data is not publicly available. I'll explain that more later. But basically, the goal of this is to provide a framework to use to help determine whether potential pathways and projects make sense. So let's talk about some of the climate harms of AI. I'd love for you to put in the chat, what have you heard about as some of the climate harms of AI and how harmful are they if you can quantify them? So I'll just give you a minute or two to do that, and you can also do it while I'm talking. Great. So I think some of you are starting to think of them and point them out. Some of the key climate harms of AI that I've seen are emissions from energy use, critical mineral use for things like chips, air pollution from the emissions, water use, noise. Data centers are very noisy, hazardous waste, as well as land use. And there's also lots of societal harms, but those are some of the climate harms. We know energy demand is increasing, and AI is using a ton of energy. So one answer or thing that a lot of people mention is, well, can't we just install more solar or wind? But the fact of the matter is renewable energy can't keep up with the rapid AI expansion. For example, in the US, the electrical grid is a major bottleneck because it takes 1 to 15 years to add a renewable source of energy like solar or wind to the grid. This is part of why we've seen some data centers using some very interesting forms of energy, like plain jet engines, for example. So some of the harms can be broken down into this AI stack, which AI Now Institute mentions. That's infrastructure, hardware, and software. Infrastructure being things like data centers and the equipment within them, hardware being the chips that AI runs on, and then software being the AI software that we use and that other companies and folks use. Here's another way to look at it. This is from a great resource called Climate Change AI. You can look at the computing level impacts. You can also look at the immediate application impacts, for example, in areas like transportation. And then you can also look at system level impacts. And I'm going to provide these slides. This presentation is meant to give a brief overview, and then there's links in it so you can dive in to learn more or check out some of these sources if you're interested. Now let's talk about hardware. So AI operates on chips, and I was surprised to learn that in the US, single fab, so one of Intel's campuses, produced about 15,000 tons of waste in 3 months in 2021, and about 60% of it was hazardous. It also consumed enough water to fill about 1,400 Olympic swimming pools and used an incredible amount of energy. And these chips often release fluorinated greenhouse gases, which can be 12,000 times worse than carbon dioxide. Now, the energy intensity of chips has decreased over time, as you can see in this graph. In fact, the efficiency of the chips has doubled around every 2.5 years. And a modern chip today uses 99% less power to perform the same calculation as a model from 2008, but it's uncertain how much this trend can continue. There's also an installed base issue. there's millions of inefficient chips that are out there already. And so even if there's new, more efficient chips, that doesn't mean that the old inefficient ones will just automatically be replaced. Similar to the phenomenon of electric vehicles, where just because electric vehicles was created doesn't mean all the gas cars automatically disappeared from the road. The demand for chips is mostly from operations. So you can see that here, the electricity demand, a small amount of it is from the manufacturing of those chips. Now let's talk about software. Again, this great resource, Climate Change AI, breaks it down into a couple key areas. There's inference, so that's sort of usage, like you and I using ChatGPT. There's also training models, and then there's development. So you can see here that development uses the most energy, followed by training, and then a small amount of inference. But then there's also a high frequency of inference, followed by a smaller frequency of training and then development. And if we were to quantify it, you can see that the training process for a model like one of OpenAI's models consumed enough to power around 120 average US homes for a year. So that is a lot of energy. And the training compute, so the usage of energy from AI, is increasing exponentially. You can see that as a graph here, and it continues to increase year over year. Now, not all models are created equally. You can see some of the models here. For example, OpenAI's GPT-3 has a relatively low amount of carbon emissions compared to something like Meta's Llama, which has almost 9,000 tons of CO2 equivalent compared to that 588. Now, the 588 might seem small by comparison until you consider some of these numbers. If you were to look at the emissions from air travel, human life, or car usage, they would be way down around the zero axis. So you can see that GPT and Llama, the training of those models, use way more emissions. A ChatGPT query, for example, consumes about 5 to 10 times more electricity than a simple web search. And these days, when you Google something, AI is automatically used as part of that. Although you can turn it off, you can also put -AI at the end of your query, I believe, to turn it off. The emissions of usage tasks really varies. So we have text classification is the lowest, and then image generation and video generation are highest. So not all forms of AI are the same in terms of their emissions, and you can really see that here. For example, creating an image with generative AI uses the energy equivalent of fully charging a smartphone. So should we be creating AI images of cats? It's really an ethical question. And the environmental impact of AI is mostly invisible to users. Only 12% of executives are using AI to measure the environmental impact of its use. And now we're going to talk about infrastructure. I also just wanted to mention, if you have any burning questions, feel free to interrupt, but we'll also have a question period at the end. So we can probably save a lot of questions for then, if that's okay. So from energy for data centers, we can look at where is that coming from. 50% of it is coming from cooling system, followed by server and storage, which is 26%. And then the rest are network hardware, power conversion, and lighting. So if we want to make a difference, we can look at these different areas and where we could reduce them. A typical AI-focused data center consumes as much electricity as 100,000 households, which sounds like a lot until you consider that the largest ones that are being constructed today will consume 20 times as much, or even higher. I heard about one that's being constructed that might use the same amount of energy as half of New York City, so that is very high. Now, data centers right now are a relatively small amount of energy demand at around 2%, according to various estimates. But by 2030, they're projected to grow to somewhere between 5 and 9% by 2030, or perhaps even as high as 21%, according to an MIT estimate, when the cost of delivering AI to customers is factored in. There's lots of different estimates of data centers' energy use and how it's going to change. But there's one thing that's clear. They're all a hockey stick, so that up and to the right curve. Just to put this in terms of scope, if you were to think of a data center as a country, they would be the 11th largest electricity consumer right now between Saudi Arabia and France. But by this year, they are projected to move up to 1/5 between Japan and Russia. So that's a lot of energy. And that sounds crazy until you consider this is already happening. In Ireland, data centers consume 1/5 of the country's electricity, and they're projected to grow to 1/3. 1/3. And AI has only really been around in a big way for the past couple of years. Where are these data centers? They're all over the place, but they're largely in the US as well as China and in Europe, and then they're starting to be placed all over the world, including some of the most resource-constrained areas. There are big differences in carbon intensity across these areas. In Ontario, where I'm from, we have a relatively low carbon intensity because we have a lot of low carbon energy and a lot of renewable energy. Whereas if you look at a country like Poland, it's a lot higher carbon intensity because they don't have as much low carbon energy or renewable energy. And then somewhere like South Australia is in between. So the idea is that since some of the computing or AI loads are flexible, like think about when you want to do your laundry, you might really want to do it at a certain time, but perhaps you're flexible as to when you do that load, and you could choose to do it at a time where electricity is cheaper and cleaner if that option's available in your region. Similarly, some AI loads, such as training, could be run in different regions when and where clean energy is available and cheap, because the carbon emissions vary about 20 times across regions. The next area is users. So corporations are a big one. In fact, most tech giants like Google and Meta and so forth walked away from their 2030 net zero commitments and said that it was because of AI. And then there's also the use of AI for nefarious purposes. So oil and gas companies have been some of the earliest and most prolific adopters of AI technologies, and they're using it to boost exploration and production of oil. So we looked at the harms. How about some of the potential climate benefits of AI? I'd love for you to put in the chat, what are some areas you're excited about where AI could potentially benefit the climate? And how beneficial do you think they could be? Like, have you heard of any quantification of that? The idea here is, what if AI could help? What if these recent advances in AI, like neural networks and large language models like ChatGPT, could help with climate change? First of all, let's take a bit of a step back. What are we talking about when we're talking about AI? It can mean so many different things. One way I like to think about it can be seen through this canvas. So we have inputs, like let's say in the example of a vacation itinerary generator, the user might put in inputs like where they want to go, what their budget is, and so forth. And then the output might be a vacation itinerary. Maybe it has, where they would go, what days, the budget, and perhaps it could be made carbon friendly and it could show them their carbon emissions. So then what happens in the middle to transform those inputs into outputs? We give instructions to the AI, or the software gives the instructions and tells it something like, based on the inputs, provide these outputs. Those three things together could be considered kind of a ChatGPT wrapper, i.e. ChatGPT could give you similar information. But if you add in data, such as talking to another website through an application protocol interface, integrating a spreadsheet or PDF or something like that, it could become a bit more proprietary and differentiated. Now, I just mentioned the simple example of a vacation itinerary generator, but you can kind of scale up this model. Like, let's say you wanted to make a neural network that uses deep learning to do predictive maintenance for solar. So basically you put in images For solar, you put in images of solar panels and it predicts which ones are broken or will be. Then you would put the images in as inputs. The output would be which ones are broken or could be. You would tell it to do that transformation. And then some of the data you might give it would be labeled images of other solar panels that are broken or not. So it can use that to help inform its answer. So you can really scale that up. Now I'm using language like neural network, and I love to get everyone on the same page through this diagram, which shows how AI, machine learning, and deep learning relate to each other. So AI is a technique that enables computers to mimic human intelligence. Machine learning is a subset of that includes techniques to enable machines to improve at tasks with experience. And then deep learning is a subset of that's based on neural networks that permit a machine to train itself to perform a task. And AI is great for complicated situations. And here's a map of the electrical grid, which is said to be the most complicated and large machine in the world. So lots of opportunities for making a difference. MIT researchers and colleagues grouped them into these areas for energy systems. AI can help with energy production and consumption, energy transmission and distribution, and cross-cutting applications. Some of my favorites here are maximizing renewable power, doing better prediction of things like solar and wind, so we don't have to build as much non-renewable sources, and in things like predictive maintenance of solar panels, like I mentioned, and informing policy. Just as an example, let's say 12 electric vehicles drive home to the same area at the same time and plug in. This could create what's called a peak load, where there's a lot of energy demand that the grid may not be able to handle. But if we had AI installed at the site, everyone could plug in, let's say at 6 p.m., and the cars could intelligently charge at different times throughout the night, so everyone wakes up with their car charged. This would mean that we don't have to, for example, build out further energy sources, which is both costly and time consuming. So we could save time, money, and emissions. And that's the concept of peak shaving or load shifting the energy load around. Some of my favorite AI solutions are demand response, so the concept I just mentioned. Also energy efficiency. Buildings, according to various estimates, are about 40% of emissions. So how can we use AI to reduce those? AI can help inform policy. It can kind of see what sort of policy is out there and what a region might be missing. We talked about the example of predictive maintenance of things like solar panels. It can also do innovation. You can do material science discovery, and it can do better prediction and optimization of things like renewable energy. So in short, AI could potentially help us add more renewable energy, switch to electric faster, reduce emissions, and reduce electricity costs, all things that are vital to reducing climate change. I talked a bit about that ChatGPT wrapper concept. And when you're thinking about what sort of AI project do I want to build, you could kind of think about it in this way, which is adapted from C10 Labs, an AI incubator. You can see those ChatGPT wrapper type projects as sort of screen AI, where maybe there's low effort, low moat. They can still be valuable. But if you want to have a higher moat, you could adapt higher effort and do dimensional AI or applied AI and work on, deep integration of data for areas like health, electricity, and so forth. And what should you build for AI for climate solutions? Well, climate change AI has this great map of, you can look at the sectoral areas, like let's say you want to enable low carbon electricity, and then you can see different AI applications you could apply. So for example, here, you could use computer vision or time series analysis and so forth. This is a great way to get started. You could also do a literature review to see what's out there and do I want to use some techniques that are already out there, or do I want to create something new? And you can also think about what's the potential climate impact of what you're doing by looking at projects like Project Drawdown's Table of Solutions or their new Explorer, which ranks different climate solutions on the basis of how much emissions they could save. Some cool platforms for building include platforms like Lovable, where you can just put in a sentence and it generates an entire website and backend. Stack AI, which is drag and drop, but packs a powerful punch and allows you to integrate with other websites. Most of these don't require coding, but if you want to use it, platforms like Next.js and Python can be helpful, or Google Colab for machine learning. But all of what I mentioned sounds very exciting. However, one of the best reports we have on how much AI for climate solutions could help says that AI could reduce emissions only by about 1.5 to 4% by 2030. So this brings us to the concept of the net climate impact of AI. One of the equations we developed is akin to a cost-benefit analysis, where we can look at the net climate impact of AI as being equal to the AI climate harms minus AI's climate benefits at a given time. We can also see this on an emissions basis, where the net emissions from AI are equal to emissions from AI minus emissions avoided from AI. But we also need to consider various other factors, such as that installed base of chips that I mentioned, the inefficient chips that are already out there. Also, the time value of carbon, which says that a ton emitted today has way more impact than a ton of carbon emitted a year or two from now, because it stays in the atmosphere and has a negative effect for that much longer. We also need to think about rebound effects, both direct and indirect. An example being Jevons paradox, which says that as a technology has increased efficiency and perhaps decreased price, paradoxically, we may end up using that technology more in such a way that it would override the benefits. And then on the positive front, there's load flexibility. A recent Duke study talks about how data centers could perhaps help with that matching of supply and demand, or shifting loads around for energy. Where does this leave us? There's this IEA report, so International Energy Agency, on AI and energy, and they show 5 scenarios. 4 of these scenarios with respect to AI show that AI increases emissions. There's one scenario which shows a drastic decrease in emissions due to AI, but they have this important note here, which says it's vital to note that there's currently no momentum that could ensure the widespread adoption of these AI applications. In my thesis, we applied a system dynamics lens and developed a series of equations and came to the conclusion that AI is currently having somewhere between a small negative effect or potentially a small positive effect. I'm not going to get into this diagram in depth, but just to give some ideas, we looked at things like balancing loops or reinforcing loops, where let's say a reinforcing loop shows that as gross world product goes up, AI use goes up, which then increases gross world product per capita, which then increases gross world product. But then there's balancing loops like AI cost reduction, which basically shows that as cost and energy changes, AI cost reduction can come down. So we should look for projects and pathways where the climate benefits exceed the climate harms. And we can also look at projects where they're at the intersection of what sort of business value they can provide, what AI capabilities they leverage, and then what sort of climate impact, but also societal impact they could have. We should also remember that AI is one of a set of tools alongside other tools like policy and so forth. And these tools sit alongside emitting sectors, stakeholders, and adaptation strategies. This is from a great course called AI for Impact by deeplearning.ai. So lastly, what can we do? I'd love to hear any thoughts or arguments from you folks in the chat about this question. Who do you think will be the guardians of AI's climate impacts and reducing those? Will it be government, business, civil societies, or NGOs? And also, where will the change come from? Like, where will reducing AI's climate impacts come from? Will it come from technology, policy, law, or finance? I've heard different answers from different audiences, and I'm very curious to check out yours. In the meantime, I'll talk about how do we address this ethical tension. colloquially, I'd put it as we have AI is awesome on one side, but then the climate is already hurting, and now we have AI. We can address it through things like constraints and frameworks, such as this framework, the Boundaries of Tolerance Framework, a pyramid of ethical progression from Jeffrey Saviano from Harvard. Basically talks about we can move along this pyramid from the bottom, which is non-compliance with laws, to reactive and basic compliance with laws, to going above and beyond laws, which are currently very limited, to doing more ethical actions and being ethical stewards to help others follow. There's currently very limited legislation in this area. The EU and the US have introduced legislation regarding the environmental impact of AI, but these policies are few and far between. They're at different levels of introduction versus being rolled out. There's emissions and gaps. And most AI strategies that governments are rolling out don't include environment, and that's said to be no less dangerous than the lack of other AI-related safeguards. So there's not much in the way of AI and AI's environmental impacts in law currently, at least in places like Canada and the US. There's opportunities for improvement in the 4 areas that I showed where AI is having an impact, these being hardware, software, infrastructure, and policy. And some of my recommendations from my thesis to industry are to boost software and hardware efficiency, transition more to renewables, address ethics, and consider the net climate impact of actions. Policymakers should consider implementing carbon pricing, which could help with not just AI, but other areas. They should require a disclosure of AI use and impact, regulate AI emissions and resources, and support research and development, training, and greening the grid. And then researchers can push for sustainability net metrics and do some of the other tactics like consider net climate impact, use more efficient software and hardware, and conduct further research and education on AI and climate. I think we should move from this model of responsible AI as promulgated by Microsoft and many others to include transparency and explainability, reliability and safety, fairness, inclusiveness, privacy and security, human oversight and accountability, to include sustainability and climate at the base of all this and include climate responsible AI. If everything I said sounds pretty crazy, you can think about this. Texas, despite perhaps having a different ideology than would be associated with sustainability, is one of the best places for renewable energy right now because it's, in the immortal words of the Daft Punk song, harder, better, faster, stronger, and I would add cheaper. So perhaps naturally through technological innovation, we will move towards that. And we could think about different strategies in terms of this advocacy strategy framework, strategies that provide awareness to the public, like public education, all the way to ones that create action for decision makers, such as litigation, regulatory feedback, and everything in between. They all make a difference. In conclusion, AI has both positives and negatives for climate. The climate harms of AI are real and measurable, while the potential benefits are pretty speculative. So if we are going to use AI for climate solutions, it should be used carefully, considering the net climate impact of AI. Some changes need to take place to reduce the impact of AI, like the ones I had mentioned, making it more efficient. Until this takes place, I think we should put in place more regulation to limit the usage of AI. AI is a key part of climate change, but it's also a threat to our climate because it's so energy hungry. And what we do matters. It's up to us. We need to steer AI in the right way. We can't put up our hands and say AI is so advanced now, it's going to figure it out. We have to shape it and control it. And hopefully it's not too late to do that. We need everyone's skills. I love this climate Venn diagram from Ayana Elizabeth Johnson. It's similar to the Japanese concept of ikigai, to do things at the intersection of what brings you joy, what you're good at, and what work needs doing. That's your climate action. A benefit is taking action can reduce eco-anxiety, according to a Yale study. Eco-anxiety being, these worries about the climate, taking action can help reduce that. And just to tie it back to what I mentioned at the outset of me sitting next to those kids in the wildfire smoke where they were asking, why can't we go outside? I want to share that there's some inspiring work going on from various groups, including, for example, a group of 27 law students in the Pacific who brought the largest climate case to the International Court of Justice and won, and then a group of youth activists who won an unprecedented climate settlement in Hawaii, and now Hawaii's enacting their first net zero agreement. And this is part of the work that I'm working on now. Reminder, this is not legal or financial advice and represents my own views. Let's work together to make our world a better place because there is no planet B. And also here are some resources, including my report on the net climate impact of AI, as well as some recordings to other talks and courses that I've done in case helpful. And now I'm happy to answer any questions.